Alright, okay, so hello dears! Ayan, so welcome to the continuation in our pre-recorded lecture on permanent stain smears. Alright, so this is now the main bulk of our topic in parasitology. And this is what we're going to perform. I think natin lab activity, if I'm not mistaken. But anyway, muna siya to ang main gist yun. Alright, so staining techniques for detection of parasites. Okay, so medyo na-stress na ako din guys. Dahil itong sa AK, daghan yung mga technical difficulties. But thankfully, naka-projector also ang ang projector as in, hapit na ko mag-buisit kaya binagdili. But anyway, thank God. Okay, anyway, so ayan. So, permanent stain smears. Now, what are permanent stain smears? This is considered to be, again, the final procedure for ONP. Diba? For ovine parasite examination, recall kung unsa to ato ang mga steps, diba? First is the wet mouth, diba? Or the direct wet preparation, diba? Direct wet. That's the first. Second is, of course, concentration techniques, which is the sediment or the flotation or the floating whatever. What's the term? The one that floated, diba, sa parasites. Still wet mouth pa rin na siya, diba? Alright. And lastly is, of course, your permanent stain smears, diba? Alright. Okay. Now, again, it contains a fixed sample. Alright. Again, it could be concentration. Pwede po wet, diretso sa wet mouth, and then ato siyang gipa-dry, fix, and then stain. Alright. And again, that has been allowed to dry and subsequently stain. Right? Itong gibutangan og color. Next, it's considered permanent by the name itself. It's one of its advantages because it's permanent, meaning you can store it for a long time, okay? And it's very important, very useful, especially in the academic purposes, because you can use it even before or even long, even kanang ways, even years pa, okay, from the time mo gigama. So you can store it for a long time. You can use it for the future, and again, very useful, very helpful for the academic purposes. Okay, very important. All right, and because it can be sealed, it can be put a cover slip. All right, and then which allows them to remain intact over a long period of time or long term. Okay. Now, it's considered to be the critical portion of the ONP because it's through permanent stain smears that we confirm. Okay, we confirm the identity. And the presence also of your protozoa, usually for protozoa yun, cysts and or trophozoites. Now, you may notice no, that most of our permanent stain smears, we perform permanent stain smears, or we make permanent stain smears. It's for the purpose of the protozoa, for identification and confirmation of the identity of our protozoa and parasites, both the cysts and trophozoites. Not so much of our helminths, eggs and larvae, diba? You'll know later why. But again, primarily, we perform or we make permanent stain smears for our protozoan parasites. Okay, alright, ayan. And it allows your lab techs, med techs, scientists to observe detailed features, ayan, morphological features of your protozoa by staining intracellular organelles. So, meaning the structures found also inside the cells, especially mga nucleus, mga karyosomes, diba, chromatoidal bodies, yes naman, mga ganun. So, which could help and could aid in the accurate identification of a protozoan parasite. Okay, alright, ayan. And identification of protozoa in our wet mounts, no, or direct preparation, they're all tentative, okay? And again, as mentioned, we confirm that through permanent stain smears. Why? Again, because through permanent stain smears, their intracellular organelles, their structures are much more enhanced, much more visualized. That's why we can identify them, okay? It's through wet mouth manggod, their features are still quite unclear, okay? And you can mistake, diba? You can mistake them for an artifact, let's say a WBC ba, or food stuff from the feces, diba? Which could lead to misdiagnosis, diba? But through permanent stain smears, because again, it also stains the intracellular organelles, we can identify them accurately. Okay? Alright, but again, as I mentioned, in the hospital setting, we often limit or we often just settle at the wet mouth. Okay? So, dili na tayo mag-perform of permanent stain smears. That's based on my experience. Okay? But I think in the other countries, in US, abroad, they perform it. So, at least now you know how, okay, to perform, okay, or what are the different methods for it. Okay, all right, ayan. So that's for some introduction. Now, again, as I mentioned, we don't usually use permanent stain smears for the identification of helminth eggs or larvae. Why? Because they take up much of the stain. So they take up much of the reagent, the stain. So what happens is their cellular morphology is distorted, okay, or they can appear too dark, okay. So dili jud sila maklaro, okay. Their structures, they cannot be visualized clearly. All right. That is why the best, the best method is through concentration techniques. Yes. And of course, our helminth eggs and larvae, they have their own specific characteristics na that can already be seen even if you don't use any stains. Like example, the eggs, distinct eggs of your different parasites. You could also the larva, diba? Strongyloides, hookworm. So it's very, very distinct na yun, defining na. So you don't need any stain. Okay, and aside from that, again, they take up too much of the stain and they may appear distorted. Alright, which would not help us in the identification. Alright, okay. Sample of choice, it's a thinly prepared slide of see-through thickness. So we make a smear very thinly from a PVA preserved sample or SAF. But the choice of stain, if you use PVA or SAF, is the iron hematoxylin stain. So we'll know later the different types of staining techniques for parasites. Okay, alright, ayan. Okay, wait sa, higutasan ko. Anyway, alright, so for fresh stool specimen, you could also use fresh stool specimen, but in the case of fresh stool specimen, we need to first it to be dried, okay, first, and then we place it into a fixative, maybe formalin, PVA ba, or SAF, okay? So a fresh stool, okay? So we let it dry muna, room temperature, yes, and then we make it, fresh stool specimen, we make a smear out of it pala. So thin smear on a slide, labeled slide, alright? And then we let it dry, and then after you put it in a fixative, or I think even before sa slide pa pala. The specimen itself, you let it dry. I don't know what's dry. Yeah, I think it's referring to the slides. Okay, basta mo na siya point. Okay, after letting it dry, you then put it in a fixative. Okay, alright. On completion of staining, again, as mentioned, the slides can be sealed using a sealant. You could use a lot of sealants. This is termed as a mounting medium. You'll know more of this in your histopathology in third year. Mounting medium. In para, we can use actually kanang Q-tips din na clear. Nail polish, yes. Na clear, yes. Nail polish lang. Or pwede natin gamitin. But there are a lot of mounting medium. Very important, and is a U-kit. U-kits. Okay, or U-kit. This is used for sealing the cover slip around your smear so that it can be preserved for a long time. Okay? Alright, but for us in para and even in your public health, you can use nail polish. Katong clear na nail polish. Okay? Ano siya tawagan na sa Bisaya? Basta clear na nail polish. Okay, alright. Ayan. And we then examine the slides since we're looking for protozoan parasites. We examine them under your oil immersion objective. And how many fields? 300 fields should be examined before reporting a negative result. So how many fields? At least 300. Okay, so you can count it naman, minimize. I think from one smear to another, end of smear, that's about 150, I think, fields. Or you can count the fields, maximum. Or you can estimate. Okay, basta at least 300 fields before you report a negative result. Okay, alright, ayan. Next, we go into different methods or different staining techniques. First is the Wheatley's trichrome stain. Second is the iron hematoxylin, and lastly, the modified acid-fast stain. So these are the staining methods that we are going to discuss to determine parasites. But there can be a lot of other staining methods for parasites. But as I mentioned, we're only focusing on the most common then. Yeah, because again, as I mentioned then, if staining talaga, it's really diagnostic or routinely used for bacteria, not necessarily for parasites in the Philippine setting. Okay, so that's why parang wala kay other methods na i-discuss. Again, these are all based from the manual of Ma'am Bernal, lab manual of Ma'am Bernal for para, and other sources. I've taken sources from Bailey and Scott's because there have been mga recall questions of board exams from my review notes then, the one that I made for when I lectured on a review center. Okay, I lectured also in parasitology there. So I included also my notes. Okay, so it's a mixture na. Alright? Okay, ayan. Para mga press the buzzer na pagdating sa boards. Okay? Dapat lang. Dapat may maraming top-notchers. Char! Okay, alright. Ayan. So start first with the weekly trichrome. The weekly trichrome stain is a modification of the Gomori trichrome stain for tissues, human tissues. Now, actually, for staining then, guys, no, as medtechs, aside from bacteria, as I mentioned, staining is also important for human tissues, for histopathology, my hate test subject. Not really hate test, but it's a subject that I'm not confident in. And basta, weak akong knowledge. But anyway, there's a lot of stains. Lot of stains for different types of tissues. Example, if you want to stain muscles, kanina siya mong gamiton. If you want to stain the neurons of the brain, you use this stain. If you want to stain different tissues pa, like example, connective tissues ba, or skeletal tissue, or whatever tissue that you receive in the laboratory, there's a corresponding stain that you may use, okay? And one of that is the Gomori trichrome stain. And usually the Gomori trichrome stain is usually used for muscles, for staining muscles, okay? So that other stains, again, sinasabi ko na sa inyo, I'm already priming you, informing you that there are still a lot of stains and you need to memorize that. You need to memorize that in your histotech. You will memorize what is the color of the stain, or what is the color of the tissue under this stain, what is the color of the nucleus, what is the color of the endoplasmic reticulum, whatever. So, more to come in your third year. Yes, handa na kayo. Yeah, so this is again Gomoris, one of that. Usually for Gomoris, it's for muscles. Okay, so the weekly trichrome is a modification of the Gomoris trichrome stain for tissue. So here's an example of a Gomori stain. So these are muscles. All right. So as you can see, these are the nucleus of the muscles. So nagana siyang nucleus. No, I think this is skeletal muscle. Oh my gosh, akong histo. Basta banga ko histo, guys. Promise, I don't like that. Wala, medyo weak akong knowledge. I need to review pa, but that's my lowest sa boards there. I don't like it talaga. But anyway, I think I'll find to like it soon in the future, but not in the near future. Anyway, alright. So, this is a muscle, as you can see, color blue. And then, you have mga nuclei, kani mga circle na red. Okay, so that's weekly trichrome. This is Gomori, and weekly trichrome is based on that, on this stain. Pero gi-modify lang siya. Alright? Okay. Now, it's considered to be the most widely used permanent stain, okay, because the reagents have a long shelf life and the procedure is relatively easy to perform. Ako lang ibutang tanan. Okay. Alright. Ay, sorry. Ayan. Okay. The sample is smeared again on the slide that is fixed with your Schodins or PVA. As you can see, parang PVA talaga yung best. The best. Di ba, I think nigawas na itong exam. Fixatives can be used for permanent stain smears. Apil ang PVA ato, and I think Schodins ang answer ato. But anyway, PVA and Schodins. MIF and SAF also can be used, but the first two, PVA and Schodin. Okay, Mark, what was that? PVA and Schodin na fixatives ang mo produce of better results. Fresh tools sample can still be used naman. Okay, and we also have what we call the modified trichrome staining, which is the recommended stain for your microsporidia. And they appear bright pinkish red. Ako, lumabas sa boards, not in our boards, but during mga previous boards. Recall question, what is the recommended stain for microsporidia? Ang answer natin, modified trichrome. Press the buzzer na ako, 1 point na. Okay, where did they get this? Bailey and Scott. Buiset, yun yung mga board of examiners like, I hate it. But anyway, diba? So at least you know. Modified trichrome, it's used for, again, stained for microsporidia. And what do they look like? They appear bright pinkish red. And you have two modifications of the modified trichrome. You have the Ryan blue method. Ryan blue, by the name itself, the background appears blue, alright, bacteria and other debris. They appear blue, and the Weber green because they appear green ang background. Okay, so muna siya difference. Nasa pangalan na. Ryan blue, the background, the debris, the bacteria is blue. Weber green. Okay, so the background is green. Okay, alright. But still the same for both modifications, your microsporidia will look like bright pinkish red, or they will appear bright pinkish red. So here's an example. The bright pinkish red, as you can see, these are your microsporidia. Now, sir, what are microsporidia? So I will not elaborate further kayo kay. It's not common yun. But microsporidia is a parasite, but they look like, okay, or their characteristics are like fungus, okay? Alright, they are like fungi, okay, but they are actually parasites. But I think padulog na po fungi, okay? And so the same, usually what they cause kay intestinal disease, okay, mga intestinal symptoms, especially those patients that are immunocompromised, okay, or those that their immune system are not working properly, okay, they're microsporidia. Again, those are types of parasites, intestinal usually, ang ilang target, that closely resemble that of a fungi, okay, they look like fungi, or they exhibit fungi-like symptoms, okay, fungi-like characteristics, okay, alright, but ang important lang, again, what is the stain used for microsporidia? The stain of choice for microsporidia, nako press the buzzer, modified trichrome. Okay, alright. Ayan. Okay, now we go now to the procedure. So we go now to the different reagents. So we'll start first with 70% ethanol. For 70% ethanol, it's used to remove your fixative, di ba? It's required or it's recommended that your stool sample be put in a fixative muna. Alright? Okay. Next, after you put the slide in 70% ethanol, okay, after 70% ethanol, you then transfer the slide to a jar. So mga jars ni sila. Okay, you transfer the slide into a 70% alcohol and iodine mixture. What is the purpose? The iodine will then remove the mercuric chloride if your fixative has mercuric chloride. Example, PVA, Shodin solution. They have mercuric chloride. So you have to immerse the slide after ethanol to alcohol and iodine. Because again, the iodine will remove the mercuric chloride. But if you use formalin, other preservatives, you don't need to you can skip this method or this step, okay? Alright. Ayan, next, after you then go to immerse a slide in 70% alcohol 2 times, so one jar, okay, so 1 jar alcohol, you put the slide there, and then another jar of alcohol, okay, 70%, okay, 2 times alcohol. Okay, why? To remove your iodine, okay. And the continuation, you then add, after 2 times of alcohol, you then put it in a jar, the slides that contains your trichrome stain, which will now serve as the stain. Okay? Alright, then the continuation, okay, after trichrome stain, you then add it to 90% alcohol and acetic acid for destaining, meaning to remove excess stain, so that naman your parasites will not be overstained, okay? Alright, okay, because they could hamper also in the identification if it's the parasites are overstained, okay? Alright. Next, we then add it to 100% alcohol for rinsing, further rinsing. Okay? Alright. Then you add another alcohol for dehydration to remove water. Okay, because we need to remove water. Okay, wait. Alright, because if there's water inside your organisms, of course, so the other structures, your enzymes, lipids, water inside of your organism, if there's still water inside your organism, the normal functioning of your organism will continue. So it can lead to destruction pa rin of your overall morphology and whatnot. So we need to remove water. Okay, alright, ayan. And lastly, for xylene, for dehydration and clearing. Meaning, we then remove the alcohol, okay, and to further dehydrate, to really get the water out. To get the water out of your organism. And clearing to remove your alcohol. Okay? Alright, yeah. And that's the end. Okay. So that's the end. So usually in your histotech, you will know the proper procedure good of staining for tissues. So you're starting fixation, then followed by dehydration, you need to remove water, and then clearing, and then impregnation, etc., etc. The steps of tissue processing, you will know that in your histotech. So you'll be introduced to the terms again, like here, dehydration, clearing. Alright, so dehydration, again, a point, dehydration with the name itself, you remove water out of the system. Okay, because again, the water can contribute to the disruption or distortion of the cellular morphology of your tissues or your organisms. And clearing, you then remove the reagent that you use for dehydration, usually alcohol, you then remove that, okay? Because alcohol is not compatible now with the next reagents in tissue processing. So you need to remove that. Usually ginagamit for clearing is xylene, okay? Alright, ayan. So more in histotech, guys, okay? As I mentioned, weakest subject, I don't like it. Okay, alright. Now we go to the results. For background debris for weakly striped chrome, it's color green. Okay. For cytoplasm of protozoa, blue-green to purple ang kanyang cytoplasm. The nuclei and inclusions, mga intracellular stuff, red to purple red, and sharply delineated, meaning you can really see the intracellular inclusions from the background. So it's sharply delineated from the background. Next, this is the table from Zydig. So as you can see, quite similar naman ang description. Background is green, cytoplasm of your cysts, light pink or blue-green. Yes, blue-green, purple. And the nuclear karyosomes or your inclusions, they could be bright red or purple red, red to purple. Okay, and here are some of your pictures. Ayan. So as you can see, E. histolytica cyst. As you can see, this is the nucleus, di ba, of the cyst. As you can see, it's sharply delineated, meaning na klaro gud mo siya ba? Na stand out siya from the background. Okay? And again, background is green, and the nuclear karyosomes or intracellular inclusions, they are quite purple-red. Okay? Alright, and here's an example, di ba? Background natin sa parasites and fecal smears, your Giardia. As you can see, the nuclei niya, mga eyes, parang eyes niya, di ba? Are again red or purple red, and the background is green. Okay, that's for Wheatley's trichrome stain. Alright. Okay. Now we go now to the next video. For the next video, we'll then discuss the next method, which is your iron hematoxylin stain. Okay, so medyo marami-raming chika. I think sa modified acid fast na part, but hopefully mahumano na to siya dayon. But yes, okay. So Pikutasan jud ko dears, I don't know why. But anyway, alright. So I'll see you on the next video. Alright, and we'll start with iron hematoxylin stain. Okay.